One day, Jen noticed that her flowers were starting to wilt, so she poured water at a rate of 1 inch per second in the rectangular prism vase. The vase has a width and length of 4.25 inches and a height of 9.5 inches. How fast is the volume increasing?
So in order to solve this problem, we first listed out all of the givens that were given to us in the problem. So we know that the height is 9.5 inches and the length is 4.25 inches, and also the width is 4.25 inches because this is a rectangular prism. So to find the volume of a rectangular prism, you use the formula length times width times height. And we're trying to find the derivative of the volume, so we use the formula dv dt equals d dt times length times width times height. And then we changed this formula around by using product rules, so we got dl dt times width times height plus dw dt times length times height plus dh dt times length times width equals dv dt, or the derivative of volume. So now it's just about plugging in all those numbers into that equation. So dl dt and dw dt are both 0 inches per second because the length and the width are not increasing or changing at all. dHdt, however, is the rate that the water is being poured into the vase, and it is listed as 1 inch per second. So now I just plugged in all of the information into that formula. That's the second row. So dl dt is 0, length and width are both 4.25, dw dt is 0, length is 4.25, height is 9.5, and then dh dt is 1 inch per second, length is 4.25 inches, and width is 4.25 inches, and that all equals dv dt. So essentially, those zeros that are dl dt and dw dt cancel out the first two parts of this addition problem. So essentially, you're just left with 1 inch per second times 4.25 inches squared. And that is dh dt times length times width, which will give you the derivative of the volume.